Hello and welcome to, I believe it's now Unit 2 for metric measurement. I will fix that up in the corner where it says Unit 1. That's because this used to be Unit 1, but they added our intro section. So today we are going to be discussing the difference in the metric system versus the US customary system. And we want to look at why we use the metric system in science. So I know here in the US, we commonly use inches, feet, miles, those types of things. But if I ask you how many inches are in a mile, you would have to do quite a few calculations. Even if I go to how many feet are in a mile, to come up with 5,280 takes a bit of a jump. So by comparison, the metric system is all based on tens as their unit. So you only ever have to move a decimal. If I say how many meters are in a kilometer, it's 1,000. How many centimeters are in a meter? 100. Everything is tens, hundreds, thousands, very simple conversions. The base units that we use for measurements are grams for weight, meters for length, and liters for volume. So mass, length, volume. Just a quick reminder that mass is the amount of matter in an object. Well, this technically has to do with the number of atoms in it. You can think about this as weight if we were working on Earth. Now, the difference there being your mass is always the same. Like if you were to travel to the moon, your mass, the number of atoms in your body, is not going to change, but the weight of your body, because it has gravitational pull, would change. Length is just the measurement of an object from end to end. Our base unit is a meter. So to give you an idea about how long this is, it's about a yardstick. Not exactly, or the height of a doorknob, commonly. I forgot, going back one, that for mass, the base unit of 1 gram is about the weight of a paper clip or the weight of a dollar bill. And volume is the amount of space a subject or object occupies. And that was length times width times height. So what do we know that's measured in liters? If I tell you to go grab me a 2 liter, you're probably gonna go grab a soda. 1 liter of something is like those big bottles of Smart Water that you commonly see. So these are the common prefixes that we are going to use. So prefix is going to be going in front of the base unit. So kilogram, kilometer, kiloliter. It's common also to say kilometer instead of kilometer. But looking back at our numbers, we know that base was in the middle. If our base unit has no prefix, back it up to our stair step here. Base is here in the middle of the stairs. If we go up 3 times, we get to kilo. Kilo is 1,000 times bigger. You can think of it as 1,000 or as 10 to the third. 10 to the third would be, sorry, my cat's walking on the keyboard again. 10 times 10 times 10. So kilometer, kilogram, kiloliter. So a kilogram is the weight of that Smart Water bottle. Not the volume, but the weight. Think of how much heft it had. And you can also think of it as 7 apples, give or take. And so it is more than a pound. A kilometer is the length of 10 football fields. A 5K run is about 3.3 miles. So kilometers are shorter than miles. And a kiloliter, so something that's 1,000 liters of water, is kind of a weird thing to think about, but a hot tub. So if we bounce from kilo down to hecto, hecto is now 1/10 of the size. So this is 100. This is 10 squared, or 10 times 10. Hectogram, hectometer, hectoliters. Hecto is not commonly used in our class, so you don't really need to worry about it, but you need to know it because it holds a place in the conversions. So this would be 100 grams of something. It's like kind of snack size. If you actually read the pictures there, it's like 113 grams on that stick of butter. Hectometer could be a 100-meter dash. And a hectoliter is actually the size of barrels that they use for fermentation, for like wine and stuff. Deca is another one that's not commonly used. It is 10 or 10 to the 1. You can spell it with a K or a C, I don't care. You'll notice on the PowerPoint, on the prefix, you can either show it as capital D or as DA. You just need some way to differentiate it from deci, which is a lowercase d. So decagram, decameter, decaliter. Decagram, 10 grams would be 2 nickels. A decameter, or something that's 10 meters long, is about a school bus. A decaliter is a pretty good sized bucket. And now we're back down to base units. So we've talked about this a little bit. Now, base unit is 1 unit. This is 10 to the 0. Anything raised to the power of 0 is 1. So grams, meters, liters. Gram is paperclip. Meter is the height of the doorknob. So which is bigger, a yardstick or a meter stick? So a yardstick, for those unfamiliar, is 3 feet long or 36 inches. If you have a meter stick, it is about 39.5 inches. So a meter stick is just a bit longer than a yardstick. And liter, I'm going to point out that 1 liter weighed the same as 1 kilogram. It doesn't go base unit to base unit. It's not 1 liter to 1 gram. So just warning you on that. Don't think the base units can be interchanged easily. Okay, so bouncing down to deci. Now we're moving into the decimal side of things. Again, you can think in terms of decimals as 0.1, you can think fractions, 1/10, or you can think exponents as 10 to the minus 1. Decigram, decimeter, deciliter. Now we're at 10 grains of salt. A decimeter would be 10 centimeters, which is about a crayon. If we look down here at the ruler, we can see that 1 decimeter is the length of 10 centimeters. So when you look at the ruler, you have a space this big with all these little marks. These little marks are the millimeters. So if we see over here, that is 10 millimeters, 20 millimeters, 30 millimeters versus centimeters here. And then deciliter, again, since we don't use deci commonly, we would have milliliters. So 100 milliliter travel size bottles. So in the US, we say you can only take 3 ounces or 3.3 ounces on an airplane. Everywhere else in the world just says 100 milliliters. Down one more is centi. Centi is 1/100th. Centigram, centimeter, centiliter. This is a commonly used one. Or not centigram, but centimeter is about the width of your fingertip. And a centiliter is not commonly used. We would say 10 milliliters instead. That's about the volume of 2 teaspoons. And that's what on here is milli. Milli is 1/1000th. So milligram, millimeter, milliliter, obviously quite common one. So when we talk about milligrams, we're usually talking about dosage, like a medicine, like on a Tylenol being 500 milligrams. Millimeter, I mentioned a little bit, is 10 of them will fit into a centimeter, but the width of your pencil lead or the thickness of a dime. And milliliter is about 5 drops of liquid. Now, you will never need to memorize all of these things. I probably should have said that at the beginning. It's just so that you have a good mental representation of these items. So when I say something weighs 100 grams, you know that it's kind of the size of a snack food. Now, as we're counting down, we were just at 10 to the minus third. on milli, or 10 to the minus 3. 10 to the minus 4 and 10 to the minus 5 exist, but there's no special prefix name for these. Now, when we move the decimal for conversions later, we need to count these spaces as something that's existing. So 10 to the minus 3, minus 4, minus 5, minus 6 brings us to micro. Minus 7, minus 8 are again skipped over. Gives us nano at minus 9. And pico is minus 12. So I'm not going to go through all of these, but you should know that if we were measuring millimeters being single grains of salt, by the time you get down to micrometers, you're looking at single bacteria. By the time you get to nanometers, you're looking at strands of DNA. And you're looking at individual atoms by the time you get to 10 to the minus 10. So pico does exist, but it's usually for things like picoseconds used in physics. Okay, so we're going to practice a conversion here. Let's say I have 3 meters and I want to know how many centimeters that is. So the acronym that I learned to use was King Henry died by drinking chocolate milk. And the last ones is just kind of knowing micro, nano, pico. You can kind of remember that they go in alphabetical order though at that point. So the first thing we want to do is find a decimal. Well, there's always a hidden decimal behind the 3, but we need our units here. For meters is going to be our base unit. So starting from base, now that hidden decimal comes into play, 3.0. Now, if I want to move from base down to centi, I have to make 2 jumps. So I also moved my decimal up there 2 times and filled in the extra zeros. And we know that 3 meters is the same as 300 centimeters. See, a lot easier than needing to multiply 12 times 5,280. Yeah, it gets really weird. Just move the decimals one way or the other. So another example here, 4.9 deciliters to hectoliters. So deci is here. We already have our decimal. We're moving up 3 spaces, 1, 2, 3. Now we're going to bounce this decimal 3 places. 1, 2, 3, put decimal, fill in the zeros. All right. Easy peasy lemon squeezy. Now, it says page 3. This was based on our previous lab manual that is not uploaded for y'all this semester. And so you don't need to worry about page numbers, but scientific notation. Actually, I'm going to stop the video here and start a second one.